All right, here we go. Question 25 from our Calculus 1, homework number 1 in WebAssign. It says use the given graph of f to find a number delta such that if 0 less than the absolute value of x minus 3 less than delta, then the absolute value of f of x minus 2 less than 0.5. And so we're going to open our notepad. I've already copy and pasted the important information over here to explain how we're going to find this solution. So what you need to know is that the distance that you are away from your target value, this number here is L. That is what we're approaching. That's what the limit is. And the distance that you are away on either side of L is epsilon. Now, we know what epsilon is because that's our number down here. The distance from f of x to L, f of x minus L. The absolute value of that difference is the distance away from L. And so that indicates that our epsilon is 0.05. So I'm going to label that in our picture. Epsilon is not 0.05, 0.5. 0.5 is epsilon. Now, if we track those over and down, you can see that the corresponding x values for the ordered pairs on the function that put us 0.5 units away from L, those are 2.6 and 3.8. And the distance those are away from our target x, which in this case is 3, remember this says the absolute value of x minus a has to be less than delta. So whatever that distance is away from A, it's got to be less than delta so that our y values are within epsilon of L. I hope that makes sense. So really all we need to do is we need to find these deltas, the distance we are away from A, and then we're going to take whichever one is smaller, because the smaller distance will guarantee that values chosen less than delta will give us y values less than epsilon away from 2. All right, so here we go. Really, this is the only calculations we need to do. We need to do 3 minus 2.6. Let's call that delta 1 for this distance. And then we need to do 3.8 minus 3. That'll give us our delta 2, which is this distance. And although delta 2 looks bigger, you can't always go by looks in these pictures. You actually need to do the calculations. So with our handy dandy calculator, we're going to start with 3 minus 2.6. As a decimal would be 0.4. So delta 1 is 0.4. And then 3.8 minus 3, well, I don't really need a calculator for that. That's going to be 0.8. And we can see that delta 2, 0.8 is actually larger than 0.4. So the delta that we need is 0.4 to guarantee that we remain within half a unit of our target limit. I believe it's 0.4. And we are correct. And that's going to do it for this problem. If you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.